Hello, welcome back again in our series on digital logic design. And on your screen, you see some kind of logic implemented using only NAND gates. So there are two input NAND gates, and those NAND gates are shown right over here. And we can see that this is gate number one, this is gate number two, this is gate number three, and this is gate number four. You have got an input A and input B, and then you have an output Q right over here. Now we want to understand what logic is this implemented using only NAND gates. So to do that, we see now, we first consider this gate, that is gate number one, and it has got two inputs, that is A coming here and B coming here, and the output of the gate here is can be written as, let me write over here, let us say the output right over here would be written as A NAND B. So it's basically NAND gate output, two input NAND gate output. So that's a NAND of two logic inputs, A and B, and then an inverter. Now this becomes an input, one of the input to gate number two, and input to the gate number two, another input is logic A. So this is one of the input to gate number two, and second input to it is this right over here. So now we want to monitor output here. So to do that, we can say the output right over here could be written as A dot B, that is a NAND of it, and then you have take a parenthesis and then another input is A and take a bar of it. So that's your kind of logic output here. Similarly, you want to see what is going to be the output here. So for that, we see the P is one of the input to this gate number three, and this same A and B is one of the input to gate number three. So the output here can be written as A NAND B, and then in the parenthesis, and then this is getting NAND with the input B. So you see now you got this two inputs right over here. Now we see that the gate number four has two inputs. The input coming here is this one, and the input coming here is this logic, Boolean expression. And the output here we want to monitor. So the output here can be written as simply, let's say A NAND B, and then you got this input right over here. Take a bar of it, and then again you have A dot B bar in the parenthesis, and then this is B, and then you have a bar here as well, and then you have a total bar. This is how your output Q is. Now it remains to see how you actually solve this. So you got to solve this, and when you solve this, simplify this expression, you can understand what logic you get at the output. Okay. So write in the comment section after simplifying this, what is the Q? Write in the comment section. Okay, this is how you basically can see that, or you see something is missing, you can always write that. So usually it should give you the nor the XOR logic. Actually the answer is XOR gate.